Three.
So we have about right at 1 minute remaining before we get started. If you have questions, this is a good time to ask questions. All right. So welcome, gentlemen. So today we'll be closing out chapter 2, right, with section 2.6. 2.6 is going to be the derivative of the, I guess you can say, the general exponential and the general log function, or the common log function. Yeah. I mean, so far all of our discussion has been centered around the derivative. Just as a reminder, the derivative is the slope of a tangent line at a point. You can essentially think of it like that. And so we introduced the derivative with the limit definition. The limit as h tends to 0, the difference quotient. It was a little bit drawn out, but then we started exploring like some sophisticated techniques for finding derivatives. So that's where we had like the power rule, chain rule, product rule, quotient rule, extended power rule. Then we started exploring exponentials, base e. And so a unique property of the exponential function is that it's its own base. So the derivative of e to the x is e to the x. And then we explore like the extended exponential derivative, or it's kind of like the extended chain rule or whatever, but it's applied to the exponential. I think we explored the derivative of log, right? The derivative of natural log was like du over u, or f prime over f. And so now we're kind of moving on to like the final concept as far as exponential and logs. So again, we introduced it with the derivative of base exponentials base e. Now we're doing generic bases, right? So keep in mind that natural log is common log base e. So now instead of the base being e in either cases, now we're doing general bases. So base a, where a can be any real number other than 0 and 1. Let me think. No, a is usually like a strictly positive number that's also not equal to 1, right? Because a negative base doesn't fit in this. 0 doesn't fit as a base. Negative 1 doesn't fit as a base either. Okay, nor do negatives. Okay, so what that means is that you can anticipate exam 1 to become available this Sunday. Unlimited attempts. You should notice that it'll mirror like the quizzes. Your grades should be updating automatically in Blackboard, right? So with the grade that you see in Blackboard is more than likely what I'm going to go with minor alterations. If your grade in Blackboard looks wrong, bring it to my attention as ASAP so that I can dig and make sure that everything is in order, okay? But it should be a live update. So as you completed your assignments, it should update. The only other thing is probably after exam 1, anything that's going to be late, I'm going to submit as 0. I mean, you can still augment it, but if you don't ever touch it, it has to show up in the grade book as a 0 as opposed to blank. So until you come back and complete those assignments, right? So again, we have all semester. Just the best course of action or the best plan is just get this stuff done as soon as possible, as early as possible. So that way you're only waiting on exams and just get your attendance, submit your exams, and you're Gucci. There was something else, but I let it go. I can't think of what it is. It'll come back when it's time. Okay. So let's get into the meat and potatoes. This looks like a fairly short section, so maybe we'll get some practice with the homework. Let's just focus here and do this, and then we'll explore some other options. So a few objectives here. One, we like to differentiate functions. Oh, I think it was something with the exam. So it'll mirror the quizzes. It's unlimited attempts. You basically have full access for the first 7 days, so you can expect it to become available this upcoming Sunday morning at 11:11. You can access it for 7 days and earn up to 100%. It's due basically the next Monday at the start of class, which is basically 7 days later. And you can work on it past the due date, but then there's a late penalty, either 5% or 10%. And so it's a 5% or 10% deduction for each question for anything submitted past the due date. So the highest you can earn when it's late is either 95% or 90%. Okay. I still feel like there's something else, but I still can't get to the bottom of what it was, so it'll come back. So a few objectives here: differentiate functions involving a to the x, and differentiate functions involving log base a to the x. So like a generic exponential and a generic the common log base a. Again, to reiterate, natural log, which we studied before, is common log base e. Okay. So the derivative of the generic exponential a to the x is going to be the natural log of a times a to the x. So one way you can kind of visualize this is like a more accurate formula. I think before, when we introduced exponential, when we did the derivative of e to the x, we said the derivative was e to the x. Actually, it's this, right? But keep in mind that if a were base e, the natural log of e is 1, right? So the derivative of e dx is a little bit easier concept to grasp. But if you replace a with e, then you get back to the old definition that we had before. So when we take the derivative of a general log, it's still its own derivative, but we have to keep in mind that it's times the log base a. Okay. So same as before, the only alteration is we got to multiply by natural log of a. Okay. All right. Let's see. Okay, there we go. So we're asked to differentiate here. Okay. So these are fairly straightforward. Again, exponential is its own derivative. So for a, let me see. I guess I'll write dy by dx. It's going to be itself times the natural log of 2. That's it. Now, if you're just feeling squirrely or froggy and you want to jump, you could like possibly show this with like the limit definition. So you could take the limit as h tends to 0 of the difference quotient of this function. You should get back to this point. That's just an exercise. If you wanted to do it, don't worry about it. If you don't want to do it, you don't have to do it there. Not right now. I don't think we ever require that in this course. Okay. Same thing here. I'm just going to leave it as the natural log of 1.4 times 1.4 to the power of x. Should be that. Okay. Hopefully this makes sense. Again, if anything isn't clear, feel free to either unmute yourself or type in the chat or the Q&A. I do monitor those. I will make sure to get you credit or get your questions answered. We would use a calculator there, but I'm gonna just leave it like this. Okay. So then f prime here, it should be what? Natural log of 3 times itself, okay, which would be this, times the derivative of the power, right, which is a 2. Okay. So looks like it's 2 natural log of 3 times 3 to the power of 2x plus 1, right? Because we essentially what we had to do there was like the chain rule along with, the derivative of a exponential function. Okay, so let's see, natural log of 2 times 2 dx. Okay, yep, that's good. 2 natural log of 3 times 3, yeah, so we got it. The device is lagging today. Okay, so that third one, we still had to apply the same technique as we did in A and B, but then we had to take it a little bit further and say times the derivative of that power, right? So if we just focus on that 2x plus 1, that derivative is just 2. So that's where that additional 2 came from. That was a fun exercise. Okay, let's see what else we got. So quick checks I usually leave as an exercise for you all. Okay, so we've explored we've introduced the notion of taking the derivative of the generic exponential function, like exponential base a. So now we want to take a look at taking the derivative of common log base a, right? So keep in mind that from before, the derivative of natural log was du over u, or in other words, f prime over f. So this is essentially the same thing with the caveat of we have to multiply by 1 over the natural log of a. So with exponentials, we multiply by the natural log of a. With the logs, when we go to take the derivative, we're still doing du over u, but we have to multiply by 1 over the natural log of a. Keep in mind, if it was natural log, if we were taking the derivative of natural log, the base natural log is the same as common log base e. So then that 1 over natural log base a essentially goes to 1, and that's where we get the du over u as before, right? So again, the derivative of log, the derivative of log.
Just talking about complex shit. He walked out with us. But sometimes I just want to listen to you. Like,
nope. Yep. Okay. Yeah. So again, the derivative of natural log is du over u. So the derivative of common log base a is still du over u, but times the 1 over the natural log of a. Okay. All right. Let's see if we can see this in action. So we have a few examples here. So for instance, for part A, we can do, if we did du over u, that would just be 1 over x. So then we have to do that little caveat, right? So dy by dx would just be 1 over x times 1 over the natural log of 8. Like, I'll put the x here. I just moved the x to the front so that we can be clear that the x is not inside the natural log. Okay. Okay. Let's work on part B. So, okay, so common log, when no number is written, just take a moment. Do you know what number is written if there's no number written for common log? Just take a moment. All right, so hopefully you're thinking it's base 10, right? So common log, when no number is written, that means it's base 10. Okay, so if we did du over u, it'd still be 1 over x. Then we got to say what, times 1 over the natural log of 10. So we could do something like x natural log of 10, like this. Okay, so usually when you guys mics are kind of going like that, that means you're joining late. You definitely want to go back and watch the intro to this. I don't know if that's going to help at all, but I can imagine coming in at this point, it would be like, what, you know? But I mean, I get it. You know, life happens, so it's okay. Don't worry about it. And again, you know how to access the recordings. I do need to update my my channel, organize a little bit better. But yeah, I can just imagine that. Okay, if you came in here, you're like, wait, what? How? What? But you know, the recording is there. Okay. So with this guy again, if we did du over u, okay, so our du looks like it's what, 2x. Our u is x squared plus 1. Let's write that a little bit better. Okay. And then we have to say times 1 over the natural log of the base. So I'll put my natural log of 3 here. I think that's everything. Duplicate. You know, and I've been kind of lax on the attendance as long as everything is clicking, we having minimal disruptions. I don't make too big a deal about it. But if it starts drawing my attention, then if I notice that people, if I notice people coming in like later and later, if it's happening often, then I'll start docking people. But for generally, I try to make it as simple as possible, as general as possible, because I feel like this topic is a beast all by itself. You know, you don't need me to just go and make things worse by stressing out about attendance and, you know, things that are mundane. You know, this topic is like already kind of, it can be kind of a doozy by itself. So I just try to make it general. Okay. And then, you know, this life, when you leave the Morehouse and, you know, you got your degree or whatever, man, it's a jungle. Like, it's wild. You can be qualified, have the degree, have everything, and just for no reason, you still can't get it. And so then you got to decide, okay, am I going to keep trying to get into these businesses, or I'm going to do my own thing? And once you decide to do your own thing, that's a whole other thing within and of itself. And that, you know, usually entrepreneurs tend to fail at least 10 times before they hit the one that actually works. It's wild out here, man. It's wild. But anyway, it's fun. At least it's not boring, right? Okay. The last one, it looks like we need to do the product rule, right? Okay, so let's just do the product rule. See, I need to do my F prime. Move this over. Move this over. That was what, F prime of X? Plate, you know. America. Okay. So F prime, right? So the product rule, first times the derivative of the second plus the second times the derivative of the first, right? Okay. So I'm just going to kind of write it here. So the first will be this. The derivative of the second is going to be, we got this natural log of 5 times x. So you just be sure to use your parentheses properly there. Okay, that's sufficient, I guess. Actually, I'm going to move it around just to clean it up a little bit. Right? Because if we said that times this, it ultimately becomes this. Okay. So we did first times the derivative of the second plus the second times the derivative of the first. The derivative of the first would be what? 3x squared. And the second is this. And that's it. We could factor out an x squared for both terms, but I don't really know that that helps us that much. So I'm just going to go with this. But what I usually encourage people to do whenever the topic of just this realm of Earth and the way everything is currently set up, I usually encourage people to kind of follow their heart and just try to do what you love to do as much as possible. If you can earn a living doing what you love to do, then you never work a day in your life. You can do things for money, and there's nothing wrong with that. But then a lot of times, you know, I think it's just important to like love what you do and do what you love. You know what I mean? Whenever possible. So, you know, everybody doesn't have that luxury, but I think we all do have that choice at some point. And it's scary starting out, but once you find your way, then it's an effort for longevity. You know, it's like just doing the job itself gives you energy versus doing something for money, but you hate it. You know, you kind of like wearing yourself down energetically. You know what I mean? I don't know if that makes any sense. Anyway, hey, I'm gonna go with these. So let's see how did the textbook do these? Let's see what results did they get. Okay, I think we got that for A, natural log of 8. Okay, B, x times the natural log of 10. Okay, C, 2x over natural log of 3 times all of that. 2x natural log. Okay, that's fine. Okay, okay. Yeah, so right here, I can reduce, right? I'll do it in burgundy. So this x cancels one of those 3, turns that into a 2. So aside from that, we got everything else the same. I forgot to simplify at the end. Okay, aside from that, okay. And we might have one more example. And it's a quick check. Oh man, we finished super early. Okay. Since what did I have on the schedule for next week? Okay. So I think that next week we're going to be moving into chapter 3. Let me check what's his name? My math lab real quick. Because if we're continuing on with chapter 3 next week, I'll go ahead and do a exam 1 review now for the remainder of class. I just want to see what's coming down the pipeline. Give me just a moment. Oh yeah, logging into this thing. Just a moment. Oh. Matter of fact, I did check it over here, but that'd be better. Sign in. Here, allow. This one. Okay. Allow this. No. This. There we go. Okay, that should work. Okay, so let's open it up. So we just finished chapter 2. I want to do a review of exam 1. There we go. We can use that right there. Now today, okay. So I think we do use next week as a review. Because if today, let me see, we have stuff due Monday, and I don't think we have anything due on the 24th other than the exam. So next week, so usually for exam weeks, what I do, I usually review that entire week for the exam. So next week, Monday, we'll probably review chapter 1, and then Tuesday, we'll review chapter 2. So, okay, so what we can do today, I can focus on 2.6, but if anybody requests or would like to work on something anything from chapter 1 or 2, we can. So like if you've been working on the homework or you've been stuck or anything like that, we can do it. Otherwise, I'm going to kind of work backwards. And again, next week, at least, more than likely on Monday, we'll do chapter 1, and then on Wednesday, we'll review chapter 2, and that'll serve as the review for the exam. So we'll save that for next week. I low-key want to start. I want to quiz myself. I just want to see. Oh, do I want to do that? I could do that. Ooh, how can I keep track of it? How was I keeping track of it before? I was doing that. Do I want to do this? It's a little bit annoying. I can't think of it right now. Okay, so let me see if it'll let me do this. There we go. Continue. Let's try this quiz. Start. And I want to get some feedback from you all. So what I'm going to do, this is why I was kind of pausing, because I was thinking of how to activate this thing, see if hopefully it's still there. If I go down to my polls and quizzes, 25 questions. Okay. So it looks like this quiz has 6 questions. So I'm going to activate this poll. But I'll tell you how we're going to do it. We're launch, because we can't use it for everything. But there is an active poll. So we're essentially going to take this quiz together, right? As best we can. So just kind of listen out. So, and we'll try to work it together. So this first question says the half-life T for a particular radioactive element is 8 minutes. Okay, find the decay rate of the element. So they gave us the half-life. I want to give you at least a minute. I'll just do this one, because I do kind of want to have a little bit of speed about it. So the half-life, right? I think we have a half-life formula. The half-life equals the natural log of 2 over K. They want us to find K. So we can actually switch the half-life with the K. So the K is going to be equal to the natural log of 2 over the half-life. So if the half-life is 8, so we can say the natural log of 2 divided by 8, and then that'll give us the result that we're looking for, okay? So let's open up our trusty dusty rusty calculator. Get it working. Which is this one. Come on. Oh, I gotta reload it. Okay. Choose the file. Choose the file. No. No. Okay, okay. Where is it? I have a copy here, I think. Calculator. I think it's this one. Okay. Reload. Ooh. Reload and refresh. Okay. So again, the half-life formula, the way I remember it is the natural T equals the natural log of 2 over K, but we want K, so we can basically like cross multiply. So then K equals the natural log of 2 divided by T. So we can do the natural log of 2 divided by 8. So it's that percent per minute. Now, is that as a decimal? Do not round it to the final answer. They round to the nearest 10th. Percent per minute. The only thing, I have to call back. The nearest 10th, right? So I think this is as a decimal, and I think we need to convert it to a percent, right? We got 0.08664, yada, yada, yada. I'm inclined to move the decimal to the right by 2, and so put 8.7% per minute. I'm going to go with that. Let me get rid of this, 8.7. Let's see if that works, 8.7% per minute. We're going to go with the nearest 10th. Okay, let's go next. No multiple choice here. The decay rate for particular is this, where it is measured in years. Find the half-life. Natural log of 2 over K. Again, K has to be as a decimal. It's given to us as a percent. So we need to do the natural log of 2 divided by the decimal. Okay. So in this case, it should be the natural log of 2 divided by 0.028. 1 decimal place. So 30.1% per year. 30.1. Let's just go with it. If you see an error, 30.1, just, stop me. All right, let's keep going, see what else we got. An athlete signs a contract that guarantees $14 million salary for 6 years from now, assuming that the money can be invested at 5.5% with interest compounded continuously. What is the present value of that year's salary? 14 million, 6 years from now. Assuming that the money can be invested with interest compounded continuously, what is the present value? Oh, so P. Okay. Okay, so it looks like PERT, right? So like the future amount, I'm just going to write it as A equals PE, or capital P, PE to the RT, right? Essentially, you might switch out the labels, but that's the concept. But we're trying to solve for the present value. We're trying to solve for P in this case. So right now we have P times a number. So if we want to solve for P, we divide both sides by that number. So then ultimately, I would do a colon, and we can say what P equals A divided by E to the RT. All right. So that's what we're gonna do. Okay. It guarantees 14 million salary. I'll do this in millions. So I'll do 14 here. Just got to keep in mind that it's in millions. E to the rate. 5.5% as a decimal would be what? 0.055 times 6. 6 years. Present value of that year's salary. Yeah. Okay. So I think we just crunch this. Let's crunch this and go with it. We'll come back and fix it if we don't get it right. So we're gonna again keep in mind that this is in millions. 14 divided by E 0.055 times 6. Close off the exponential, close off the denominator. 10 million? 6 years? I don't know about that. That might be the case. It's kind of weird. Round to the nearest dollar. Do not include the dollar symbol in your answer. So this is 10 million. 1, 2, 3. So we have to move the decimal to the right by 6 places. I'm gonna go with it. It looks a little weird, but 0.055 times 6. Yeah, I'm gonna go with it. So 10,064 nearest dollar 9932. Let's see. 1, 2, 3. 1, 2, 3. Nearest dollar. Okay. All right. Well, I'm gonna go with it. Take the derivative. Okay, so this is what we just introduced today. Exponential is its own derivative times the natural log of 16. So if I take some notes here, we would say what the natural log of 16 times 16 to the power of t. Oh, that's it. Was that it? The derivative of log is du over u times 1 over the natural log of the base. So this would be 1 over, we're going to have the natural log of 4. I'm going to put this x in front of the natural log, so that way the computer doesn't think that the x is inside the natural log, right here. I could use parentheses, and that should work as well. So the little thing I had to the side in Zoom is if we had multiple choice options, but I don't think we got any. Oh shoot, we got the product rule here. Okay, so the first would be this guy. The derivative of the second, we're going to have this natural log of 2.5 times 2.5 to the power of x. Okay, so ooh. Okay, well, it's gone now. So the exponential is its own derivative times the natural log of the base. So we said the first times the derivative of the second plus the second, which is this 2.5 to the power of x, times the derivative of the first. I'll put the derivative first here. It's going to be 4x cubed. I'll put it in parentheses as well, 4x cubed. Okay, we could factor out an x cubed, but I don't think that really helps us any. We could factor out a good amount, actually, but it may or may not take this. Let me see. Because we can factor out x, 2.5x times x cubed is what we can factor out, because that's what they both have. It doesn't say simplify or anything like that, so I'm going to go with it. All right, here we go. Moment of truth. Let's see. Okay, let's look at question 2. I think it was the percent thing. Half-life, 30. Let's see. Decay rate particular is this, where time is measured in years. Find the half-life. Half-life is what? T equals a natural log of 2 over k. Maybe I'll try something in the calculator wrong. Find the half-life. It should be the natural log of 2 divided by, I think I did type something wrong in the calculator. Let me pull it up. The one where we said natural log of 2. Hopefully it was not that one. Oh, no, I don't think it was that one either. Let's keep going. And I think that was supposed to be an 8 instead of a 3. That might be what it was. I think that was it. Yeah, I think I put 2.3 and it's supposed to be 2.8. So I definitely typed it in the calculator wrong. So if I change this to an 8, I think we're good. We should get 24.8 and we got it. Yeah, we just typed in the calculator wrong. Yeah, that happens. So like, again, if I were the student, either I can decide to accept it or just take it again. But we got everything else right. Like, so it's not like we don't know what we're doing. What time is it? I kind of want to do it again because I want to see that score, but I was like, it's okay. But again, that error was we just typed it in the calculator. Okay, let me see the time. We still got a good amount of time, so let's keep going back. Oh, and that was 2.5 and 2.6. Okay. Do we want to do another quiz? You know what? I just can't help it. I gotta do the quiz again because I think it's going to go quick since we know that what we were doing was proper and we found the error that we made. So it should be quick, like less than 5 minutes. Half-life is this. Find the decay rate. T over the natural log of 2 over K. So K equals the natural log of 2 over T. Okay. I guess I can leave that. So then we'll do the natural log of 2 divided by what? 7? As a percent, nearest 10th, 9.9% per minute. Let's just go with it. I think that's similar to what we did before. Next. The decay rate for particular is this. Find the half-life. Okay. So T equals the natural log of 2 over K. Okay. So we're just going to do the natural log of 2 over, as a decimal, 0.029. Let's try to make sure to type it proper this time. Half-life, 23, round to 1 decimal place, 23.9 years. Okay, let's go to the next one. 8 million from now, yada, yada, yada. What is the present value? So it was P equals A over, okay. So the future amount is 8 million divided by E to the power of R. So it's a decimal, 0.056. And 6 years, so times 6. Okay, let's go with it. Nearest dollar. 123, 123. So that's going to end in a 5. So that's 5, 716, 985. That's the nearest dollar. Okay. Natural log. So it's going to be 22 to the power of T times the natural log of 22. Let's just go with it. Okay. 1 over X times the natural log of 8. Okay, I'm going to go with it. Product rule. Ugh. How many more questions? This last one? Okay. So the first times the derivative of the second. Okay. That's going to be what? 6.6 to the power times what? The natural log of 6.6. So that's the first times the derivative of the second plus the second times the derivative of the first is what? 6x to the power of 5. Okay. Okay, let's see. How do we do this time? Submit. There we go. Yeah. Okay. I told you, it's like, okay, because the first round we were thinking, the second time was like, okay, but we knew what we were thinking was proper. We found our error, right? Because we typed it in the calculator wrong. So then that, like what you just experienced there is what I kind of expect you all to do, right? So if you take a quiz, you don't like the score, find out how you got it wrong or why it was wrong, and then go back and do it again. And then, you can honestly, it's possible to score that quick. And so what you'll discover on the exam, it'll pretty much be a similar format as these quizzes, just longer. It's going to be like 20 questions, 20 odd questions or whatever. Okay, so let's see. Okay, let's kind of work backwards. I like the quizzes, right? Because it's a little bit more challenging than the homework. The homework, we have a lot of support. Let me do the previous quiz, continue. Because it'll serve as a decent review. Unlimited attempts, the system is set to take your highest score. So you have nothing to lose and everything to gain, kind of deal. I'm gonna leave my calculator over here and clear. Let me see. An initial investment P at an annual interest at the time T are given. Find the future value of the investment when it's compounded annually, monthly, yada yada. Then find the doubling time. Okay. So this sounds like compound interest. The only thing that should be changing is our N. Let me think. The future value. So we're trying to solve for the future value. So we can actually create a formula. The principal is the 4,500 times 1. I'm using a compound interest formula, 1 plus R. So that 2.85% as a decimal is going to be 0.0285. Okay. R over N. N is going to be a variable because that's what's going to be changing. And then we're going to say to the power of N times T is 4 years. So 4N, or in other words, 4X, right? So again, I'm using a compound interest formula, and I'm just kind of taking my notes on the fly. I think it all looks good. And so this way, we can just evaluate this for those varying values of N, and everything else is constant, okay? So I'm going to go to variables. I want to evaluate this function. So for the first one, it says if it's compounded annually, that means our N is 1. So I'm going to let my X be 1, type an integer or a decimal, round to the nearest cent. It would be 35 cents, so 50, 35, 35. Okay, 50, 35, 35. Okay. Again, wait, nope, because we got to do all of them. Okay. Oh, and then we still can't get any feedback. Let me zoom out some, get a better image here. And we're not going to get feedback until we submit the quiz. So that means, we got to do our best, because we get it wrong, then now we got to decide we're going to keep that score, we're going to do it again, right? Monthly means our N is 12. So now I'm just going to recall, and instead of evaluating when X is 1, now I'm going to evaluate it when X is 12, or in other words, when N is 12, okay? Future value, now you're doing this thing. Okay, 50, 42, 70. So 50, 42, 70, okay? Daily, that means our N is 365. 365. 50, 43, 36. 50, 43, 36, okay? Compounded continuous. So for continuous compounding, we got to use PERT. It's going to be our P times E. Yeah, we can't use the poll right now because we're not getting any multiple choice. So I'm gonna just let the poll run for now. Times E to the power of R times T, so the rate 0.0285 times the time is 4 years. Okay, so that's continuous. Should be the largest so far. 50, 43, 38. Ooh, they might mark that one wrong. Because like when they do it, those tend to be a little bit close, but I'm still gonna go with what I have. If something like that happens, just bring it to my attention. I'll look at it, and I can give you credit retroactively. You can challenge the results if 50, 43, 38. Because sometimes they do their rounding a little bit weird sometimes. So that's why I was like, just you can challenge it. The doubling time. So I think we have the rate. Let me think. Now, half-life, I think I'd rather do the calculation. Okay, I kind of want to write it out. Let me think. I'm just going to kind of do it audibly a little bit. So if we're using PERT, right, the future amount, we want to finish with twice our starting amount. So we're going to have like 2P equals P e to the RT. So then 2 equals e to the RT. Natural log of 2 equals RT. So T equals the natural log of 2 over R. What's our R? Okay, so we're just going to do the natural log of 2 over R. I guess that's fine. I guess I was hesitant thinking that the half-life shouldn't be the same as the doubling time, but when I just did it, I got the same formula, so I'm just going to go with it. We got natural log of 2, if I can get this typed in properly, divided by R, 0.028, okay? That should be the time it takes for it to double. That's what I got, so 24 years. I mean, it's fine. Rounds to 2 decimal places, so 24.76 years. Oh, I hope this is right, because I don't want to do this again. 24.76. I don't even know if we're going to have time to do it again. Okay. Let me think about it one more time. Yeah, I think we're good. Yeah, we're good. Let's go on. So given the natural log of 5 is this, natural log of 13 is this, find the natural log of 65. Okay, so this is using the rules of logarithms, right? So what's 5 times 13? 50 plus 15 is 65. So 5 times 13 is 65. So then that 65 is the same as the log of 5 times 13. So the log of a product is the same as the sum of the logs. So we basically just add these two answers together to get our result. Let me see. It's a 7, 11 carry 11 carry the 1, 3, 4. So 4 point this. Oops. I'm just gonna go with it. Again, this is showcasing the product rule for logs. The log of a product is the same as the sum of the logs. So then if we just add those two results, that should be what it is. Okay. We still got a solid 30 minutes. All right, the derivative here. Okay. So the derivative of x to the 5 is what? 5x to the power of 4. The derivative of e is itself. So I'm just going to go ahead and write a copy. 8 times e to the power of 7x. But then we have to say what? Times the derivative of the power, which is going to be times 7. So 56. I'm going to change the 8 to 56. Okay. So for this, the derivative of e is itself times the derivative of the power. The derivative of the power is a 7. So 7 times 8 gave us the 56. I'm going to go with that. Okay. So chain rule here, keep in mind that square root is the same as to the power of a half. So when we do the chain rule, it's going to be the derivative of the outside function times the derivative of the inside function. When we take the derivative of the outside function, the power comes down, right? So that's going to be a 1/2. We're going to go, and it's going to be to the power of a negative 1/2, because you bring the power down to subtract 1. The inside essentially stays the same for right now. And then we have to say times the derivative of the inside function. The derivative of e to the x is itself. The derivative of a constant is the constant. It might take it like this. We can rewrite this where you have a radical in the denominator and the e to the x in the numerator. I'm gonna leave it like this because I want to see if it accepts this or not. This is a little bit quick. I'm not seeing any. I mean, I know you guys are still there. I'm not seeing any questions or anything, so just that's the only reason I'm going. Let's keep going. Product rule here. I'm gonna zoom in just a little bit. So the product rule: first times the derivative of the second plus the second times the derivative of the first. So the first is this guy. Okay. The derivative of natural log is du over u. Okay. So that's going to be 8 over 8x, which is just 1 over x. X to the 5th divided by x is just x to the 4. I just didn't write out the stuff. I just wrote the result. I kind of said the steps audibly. First times the derivative of the second. Wait a minute. Okay, I did the first times the derivative of the second, but I still got to go back and say I almost got that one wrong. So the first times the derivative of the second plus the second times the derivative of the first. Yeah. Where it is. So we need to do plus the second times the derivative of the first, is going to be what? 5x to the power of 4. Okay. Okay, I think that's decent. Oh, we got 8 questions here. Let's keep going. What time is it? All right. So the derivative of natural log is du over u. Okay. So du, let me go ahead and do my bar. That's going to be what? 12x minus 5. Okay. And then u just persists. So 6x squared minus 5x plus 4. Okay. All right, let's keep going. General form is basically PERT. Usually that's our R. Let me think. General form. It's usually like P naught times E to the. In this case, it should be. I think it's a negative KT. I think we're gonna get this one wrong. Our K in this case looks like it's. Is it 7 or is it -7? I'm going to put a 7 here. I'm just kind of piggybacking off of like how it showed up in the notes. Because when we first introduced it in the notes, it was a positive and the K was positive, everything is fine. But it showed up again. The second time it showed up, it had a negative, like where it has the -7A up top. You know what? We can just take the derivative to make sure it works. I think the P is usually like a C. I think that's a C. I mean, it's just a label, so as long as you have something there, it should work. So then, what if we wanted to check before we went forward? What we can do, what this is saying is that when we take the derivative, the answer should be a -7 times the original, right? So the derivative of E is itself times the derivative of power. The derivative of power is a -7, so this does work, right? It's gonna ultimately we're going to get a -7 times the original. Yeah. So that's one thing, like with this, like, because again, I did hesitate with that the sign on the power, so I was like, okay, well, let me just check it. You check it by taking the derivative. We should finish with a -7 times the original, and we do. You know, there's still a little bit of, you can still argue with this C, but I think we worked one before where we let C be 1 and it marked it wrong. They were like, no, you need to have that variable there. So that's because we had that experience together. That's why I put the C there. Okay, and that's kind of how it goes. When you get it wrong in the homework, then when you're responsible for it, you remember the pain of getting it wrong. So then you're like, you know what, this is what happened last time, so let me adjust based on what happened last time. If you don't do the homework, then that's a whole nother round, right? Because eventually you're going to be responsible for this stuff in a proctored environment. It might not be with me specifically. Maybe the next course, you know, they're going to expect you to know this stuff, right? And if you don't learn it, then it's just going to like snowball. Because you're gonna, usually what happens, like if you shirk it off, you're always gonna be like running from it, as opposed to actually, since you have this dedicated time, you know, do what you got to do to get through, but try to learn as much as possible, right? It's not, the rigor is reduced, so you know, do what you need to do, but still try to maximize you know what you're learning, what you're absorbing, because you know you don't want to get caught downstream without a paddle. You don't want to get caught downstream where you are going to be in a parked environment. You're only going to have like a calculator and some paper, and you know if you don't know anything, you would have wasted your time, which is what I'm a little bit nervous about. But you know, all I can do is just offer a warning. You know, and I mean, I could make things more rigorous. I could change a lot of stuff, but I don't think it's necessary for everybody's sake of mine, right? So I intentionally kind of make it a little bit gentle and just try to harp on, you know, you all are adults, right? So if you decide to shirk this off, you got to deal with the consequences of that. If you decide to maximize what you're absorbing from here, again, you reap the rewards or whatever, because you know, again, we're all adults, so we have to, there's consequences for the choices that we make. We all have to deal with that kind of stuff, right? So the sooner you can kind of like wise up to that kind of thing and just take charge of your experience. You know, it's like when things go sideways, we don't have anybody to blame but ourselves. When things go right, we deserve all the glory, right? I mean, you know, a lot, we do tend to externalize a lot, but you know, it's really you. It's not anybody else. You know what I mean? So that's just one of those lessons. That's just one of those things. So, and you got to just allow people space and time to kind of come to that conclusion on their own. Okay, we got what? At least this is the last one. We still have a solid 15 minutes. We're not going to use the whole 15 minutes. Like we get out at what, 7:15? At least by 7:05, somewhere between 7:05 and 7:10. So that gives us a little over 10 minutes. That's fine. Okay, so the size of a certain insect population is given, where T is measured in days. At what time would the population equal 1,500? Okay, so we set this guy equal to 1,500 and then solve for T. If we set it equal to 1500, we can divide both sides by 300. I think we get like a 5. Take the natural log on both sides, so then we get this 0.02t equals the natural log of 5. So then t equals the natural log of 5 divided by 0.02. This is just me saying it out loud. Hopefully that made sense. If it doesn't, just write it down. Like if you write it, you'll see it a lot better. And let me recap real quick. So we set the population equal to 1500. So we have 1500 equals the right-hand side. Then we're trying to solve for t. So we divided both sides by 300. 1500 divided by 300 is what, 5? So then we have 5 equals e to that power. We take the natural log on both sides. So we have natural log of 5 equals the power, which is the 0.02t. So then ultimately t equals the natural log of 5 divided by 0.02. Let me put it here. Natural log of 5 divided by 0.02. Okay, that should be t, the number of days, 80, round to 1 decimal place, so 80.5 days. Man, this one has a lot of openings, so I think we'll be lucky. We'll be lucky to get these right. Again, but the way it goes, when you get it wrong, just go back and try to figure out what you did wrong, and then try to adjust. When you know better, you do better. Oh, okay. And I told you it was that one with the rounding, because they do some weird rounding sometimes. Let's look at it. Let's look at it. It might be that last one. Yeah. Okay, let me think. The doubling time. Let me think if I can get to the bottom of this one. I think it's usually something with the rounding there. Doubling time, right? If we start with P, we finish with 2P. I'm using the PERT, e to the RT. So 2 equals e to the RT. Natural log of 2 equals RT. T equals the natural log of 2 over R. Okay. I think that's what we did. Let me see if I can pull it up in the calculator. Because maybe we typed something in wrong again. Moving kind of quick. Oh, you're not going to let me? Oh, no. I don't think we have it anymore. Okay, that's okay. Let's see if natural log of 2, and then sometimes they do weird rounding. Let me think. Natural log of 2 divided by R. 2 decimal places. Let's see. Natural log of 2 divided by our R is 0.0285. 32. Only thing I can think is we typed something in the calculator wrong, because we got the concept proper. And I know this is what we said. Yeah, I just think we typed something in the calculator too fast, because we definitely did the same thing. We got a solid. I want to maximize this 10 minutes. Darn. We got it right. I think we just typed something. We typed something wrong. That's the only thing I could think. I was trying to pull it up, but it didn't show. I personally would take this result. 92 is an A. I'm good with it. And again, it's not like we were lost. Like, again, it's just a keystroke thing. I mean, everything else was, I kind of want to do one more. We got 10 minutes. I kind of want to just work on the next one. Let me see. So we just did. No, we did that. We did chapter 2. Okay, let's. I think we did this one. No. Okay, I'm gonna go ahead and do this one from week 3. I'm gonna try to do a speed run. I want to finish within 10 minutes, so let's just go with it. Continue. Start. How many questions? 8 questions. Oh my goodness. All right, 1 minute per question. Let's get it. Okay. Find the derivative. Not too bad, right? So the derivative of a constant is 0. So I'm just gonna go 0 there. On to the next one. We should probably rewrite that as a negative power. See, low D high, so if I said the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom square. Okay. Give me a moment. So bottom times the derivative of the top minus, so double negative is gone. The top, which is this guy, times the derivative of the bottom. So 7x to the 6, 63, 630. top times x to the power of 6. So the bottom times the root of the top minus the top times the root of the bottom over the bottom squared. So 7 times 2 is a 14, x to the 14. So here we would have x to the power of 14. But if we have 6 on top and 14 on bottom, I can get up there. Come on. There it is. That means these 6 are gone. 14 minus 6 is an 8. 8 remain down here. And double negative is positive. I think this is it. I'm going to go with this. I'm watching the clock. I use the product rule to find the derivative of the function. Find the derivative by expanding the product first. First times the derivative of the second. So it should be a 3x squared. There it is at the bottom, right? So the first times the derivative of the second, right here, that's going to be what? 3z squared minus 2, okay? So that's the first times the derivative of the second plus the second times the derivative of the first. So negative 2z. Okay. All right, so that's that part. Expand the product first. I do not feel like doing this. Using either approach. Simplify your answer. Yeah, I don't feel like doing this. Okay. So 6z to the power of 3 minus 12z plus 24 minus z to the power of what, 5? Plus 2z to the power of 3 minus 4z squared. Okay. I don't think we have any like terms. So then expand the product. Okay, I think that's the expansion. And then when we go to take the derivative, what time is it? Okay. I'm going to try to put this in descending power order. So negative 5z to the power of 4. Okay, we do have some like terms there. So 6 and 2 is 8. So then plus 24z squared. Okay. I think there's only one squared term, so the 2 comes down, minus 8z. The power of 1 to minus 12. And the derivative. And the derivative of a constant is 0. So with the above, the like terms, I think with the above, what we'd have to do is expand it out and then simplify, combine like terms, then we should get this result. But I'm just for the sake of time, I'm just going to go with it. Oh, man. Oh, we stand a chance to get this wrong, too, because I'm rushing and I don't feel like doing it. But anyway, let's keep going. Okay, so differentiate. And this will be it. Once we finish this assignment, we're going to call it a day. We have to use the product rule. So first times the second. This one might be a little bit weird. So the first, 7x squared plus 3. The derivative of the second is 4 plus the 1/2 comes down times x to the power of a negative 1/2. Okay. So that's the first times the second plus the second 4x plus the square root. second times the derivative of the first, 14x. Okay. Do we have anything similar that's going to combine? I don't think so there. Yeah, I think I'm going to just go with this. So let's wrap this up. Come on. Let's go. Using the chain rule, so the derivative of the outside function times the derivative of the inside function. So we're going to have the 1/2. We're going to have this 8 minus 5x to the power of a negative 1/2. And then times the derivative of the inside function is just going to be what? Negative 5. So I'm going to put the negative 5 over here, right there. And I'm going to go with that. Man. Oh, you know what? No, that's not going to be any easier. We got to use the product rule here. Product rule and chain rule. So the first times the derivative of the second. So that's going to be a 4. This persists. X squared plus 1. That's now what, a 3 to the power of 3. And then we got to say times the inside function, the derivative of the inside function, which is just 2x. Okay. I guess we have to come back and simplify that. So we did the first times the derivative of the second plus the second times the derivative of the first. The derivative of the first is just a 1, so this is like the second just persists. Plus 1 to the power of 4. Okay. If I combine like terms here, we can kind of move some stuff around. The 4 times 2 is an 8. That's going to be an 8x squared here. 8x squared. Okay. And this is gone. Okay. I'm going to go with that. We could factor out that x squared plus 1 to the power of 3. I mean, that would change it. So let me simplify it. Come on. All right. So if we factored out that x squared plus 1 to the power of 3, what's left? So we have an 8x squared, and we have an x squared plus 1. So that'll make that a 9x squared plus 1. Okay, I think this is okay. Is there a space in there? There is a space. No, it's not. I'm going to go with that. Okay. 2 more. Second derivative. So it might be easier for this one to rewrite it as x to the power of a negative 6. And then when we're going to take the derivative, we're going to get what? Negative 6x to the power of a negative 7. And then we take the derivative of that guy for the second derivative, 3642, 42x to the power of negative 8. Let me get rid of my notes. A couple more minutes. I think we got like one more. Yeah. This is a speed run. I'm tired. Okay. Second derivative. Okay. So let me rewrite it first. Instead of a radical, instead of a radical, I'm going to write it as a rational power. So we got this x squared plus 9, like this, to the power of 3 over 4. So now when we go to take the first derivative, the 3 over the 4 comes down. Inside persists, x squared plus 9. That's not right. X squared plus 9. And it's to the power of a negative 1 over 4. Okay. That's the outside function times the inside function is going to be what? Times 2x. So this is going to turn this, I'm going to turn this into a 6. And this is an X. 3 over 2. Okay. Okay, let's go with this. Is this the last one? All right, let's see how do we do for speed run. My mind is jello at this point. We did 3 quizzes. Submit the quiz. Let's see. Oh, okay. Let's go. Let's start here with question 3. Let's see. Okay. Simplify. Oh, we didn't simplify. Yeah, because the 6z, no, yeah, there it is. 6 and 2 would be an 8. I think that's the only one. 8z cubed. Everything else is fine. Yeah, we just didn't simplify there. That's fine. And then this one, I think I just gave up. Let's see. Oh, it's just the form we put it in. It's probably because we have a negative power. Yeah, and we need to rationalize it. So I think what we have is fine. X squared. Yeah, I think we need to rationalize there. Yeah. Hmm. Yeah, only thing I can think is rationalize. I just don't feel like doing it right in this moment. Let me think. We had the 3 over 4. We brought 3 over 4 down. Is that what we had before? It should be a negative 1 over 4. I think we just need to rationalize it, and I'm just not doing it. Okay, guys, my mind is spent. If anybody wants to see that, I'll work it out. I'll take some time and work that out. But you have to rationalize. It's base 4, so it takes a little bit of effort there. Okay, but I think I'm done. Are there any burning questions? All right, so we got through about 3 quizzes, right? We did some speed runs and highs and falls, you know. Okay, so yeah. All right, so again, exam 2, you can anticipate it become available this upcoming Sunday, right? I think I usually make them available Sundays at 11:11. You can work on it for about 7.5 days. It's going to be due a week from the following Monday, so basically 7 days later at the start of class. To earn 100% and then pass the due date, it's a late penalty, either 5% or 10%. Next week, what we'll probably do, we'll probably review like on Monday, we'll review chapter 1. So I think there's a study guide there. It's just for practice. You're not required to do it. It's just practice if you want some practice for review. And then on Wednesday, we'll review chapter 2. When we're in class, you can ask questions about anything, even your exam. If you're working on your exam and you're stuck and you have questions, you can ask questions from your exam during class, right? And we can work on it together, all right? So, if you have questions, kind of keep that in mind. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And we'll meet back on can't get my words out. We'll meet back on Monday to be reviewing for the exam. All right, guys. Have a great weekend.
You too, Professor.
Yep.
All right, Professor.
Gentlemen. So I'll update attendance and I guess my YouTube. I'm gonna just go ahead and try to do it now. Okay.